From our previous video, we talked about the Heck reaction, which is more about exploring palladium and how it's able to perform these four steps, which is oxidative addition, which occurs around this particular region right here. And then when you add your halide into your specific catalyst, which is what you have right here, you'll have a situation where we're able to insert an olefin where a specific bond is highly sensitive to that olefin's double bond, which is the pi bond, and what results in is the coordination of that particular alkene bond to that particular metal, and that results in a migratory insertion process that is called carbopalladation, where we have a palladium carbon attached to a particular alkyl site right there. And what happens next is that we have another type of elimination called a beta-hydride elimination that then pushes our product into a last final step, which is called a reductive elimination, where we're able to regenerate our catalyst that will be used for the next step. Take note that the catalyst that is the starting catalyst must be a reactive one, which means that it will have a 14 electron complex before it gets into the 16 electron complex after it performs the oxidative reaction and coming out of the reductive elimination, which is around this region. Now this is kind of the skeletal overall reaction that is occurring in the Heck reaction. Now moving into a case scenario, we're going to be able to identify this particular reaction right here, where we have first we'll identify this to be a heterocyclic halide, and this heterocyclic halide will be reacting with another type of heterocyclic alkene, and this will be done in the presence of a metal complex right here. Take note that this metal is attached to 3 ligands right here, and then this metal complex, I'll put as MC, will also be subjected to the base, which is what we have right here. And once we have our base and our complex metal, we can be able to form our product, where we have this particular region of our heterocyclic halide bonding with this particular alkene right there to form this. Now this compound here is regional selective in terms of this catalyst advantage in this particular formation of the product. Now the purpose of this heterocyclic halide right here is to be able to perform first oxidative addition on our particular metal complex, and the next step would be to introduce your heterocyclic alkene, where it performs carbomethylation, or you can call carbopalladation, and together at the end they'll be able to perform a beta-hydride elimination. So that is out of the way. We also know that for the purpose of our metal complex is to be able to be the catalyst, and the catalyst, as we talked about on our previous video, means that the palladium has to be palladium 2+, and most importantly must have a 14 electron complex for that particular reaction to begin oxidative addition. Now take note that in this particular part, our base is to be able to perform a reductive elimination. That is the purpose of our base, that will regenerate our palladium, that will perform another cycle of the reaction. So now that's out of the way, we're going to now dive into the execution of this particular first identification and then purpose. What we see here in this particular first step here, we'll say first step, is to be able to create a 14 electron complex coming from a 16 electron complex, which is what we have right here. So what is going to happen is that this particular metal palladium complex is going to be able to lose one of the ligand in order for it to have a 14 electron complex, which is what we have right here. And this 14 electron complex is known to be very reactive. So as a result, once you introduce your first particular reactant, which is your heterocyclic halide, as drawn like this, we're able to perform the first step, which is palladium picking up this heterocyclic section, and then this becomes a good leaving group and then bonds with the palladium, and this palladium, which is palladium 0, now changes its oxidation states to palladium 2+, and at the top here we're going to have bromide, and on this other side we're going to have the other section, which is the heterocyclic part with sulfur on it. Now we're able to generate this particular step product. Our next step is to perform migratory insertion called carbopalladation after we performed our oxidative addition right here. So in here we're going to perform our carbopalladation or carbometallation, and what happens in this case is that we're going to introduce our next reactant, the alkene section right there. We notice that this section here is going to be sensitive to this particular segment of our alkene, because the palladium carbon here is actually a sigma bond that is really attractive towards alkenes. So what is going to happen is in our intermediate we'll have a complex where we have a pi complex generated, and this part we have a B, R, and there is a pi complex which has this particular nitrogen right there. And once you have that, we're going to have this other heterocyclic compound right there. And what is going to happen is we're going to perform a carbopalladation, where we have this bond cleaves and forms a bond right here, and then this pi bond forms a sigma bond with palladium right there, and what that results in is the formation of this particular product. On the other side we have our bromide right there. So once we have generated this product, our next step is to notice a hydrogen which is hanging right there, and this hydrogen is going to perform a beta-hydride elimination with this particular metal complex. And what happens is that this hydrogen migrates over to this particular metal, and then this bond cleaves and forms a pi bond, and what that results in is the formation of our product, which is what we have right here. This particular reaction here is called a beta-hydride elimination, and once that's out of the way, we'll be able to generate catalyst, which is what we have right here, where we have bromide and we have a hydrogen right there. Take note that looking at the metal from the beginning, it still has a 2+ charge right there, and they are actually all 16 electrons from this to that to this to that right there. They still have a 16 electron complex that is maintained, and then finally we actually introduce our base, and what the base does is that it actually regenerates our metal catalyst that has a 14 electron complex. So what happens is that this comes in and picks up the hydrogen, this bond actually gives it 2 electrons back to palladium, and then we have a good leaving group that then results in the formation of our salt right here, and our 14 electron reactive catalyst complex, which is what we have right here, that continues our cycle right there. So that is about it for this particular video. Hope you're able to understand this particular application of the formation of a heterocyclic product that is from two heterocyclic alkene and halide, using a palladium catalyst and activating that and using the base to actually regenerate our catalyst right there. So all the same, thanks for following me through this. Truly appreciate it. Hit the comment down below, let me hear your thought about this, but that way I can talk to you all later. Stay smart and believe in yourselves.